Hello students. So today we will see what is floating point representation, how to represent any number, any given number in a single precision or a double precision format. Okay, so what is actually a floating point representation? Point representation means the binary point can be floated towards the right or towards the left of a fraction number or any number which is given in the fractional form. Okay, so if you are trying to move your binary point from towards left or towards right from any actual position, then we call that number as a floating point. Okay, so there are some IEEE 754 formats to represent this binary number. This floating point number is in different ways, that is single precision or double precision format. Okay, so there are different more types of formats used, that is half precision, octal precision. Okay, but we are mostly using or most probably used format is a single precision and double precision. Single precision is also called as a 32-bit format and double precision is called as a 64-bit format. So to represent a number in a single precision or a double precision format, always there is some prerequisite that how the number should be. And then that proper way of your binary number can be easily represented in either a single precision or a double precision format. Okay, so always a number should be in a binary form and it should be represented as 1.m into 2 raised to any exponent. That exponent might be positive or negative, and the sign of your number would be minus or plus. Okay, so positive or negative would be your binary number. It should be represented always with a 1 plus form, 1 point m into 2 raised to exponent, plus minus exponent. Okay, now if any number is given in a decimal format, if the given number is in a decimal form, first you need to convert that decimal number into binary form first. So first convert that decimal number into binary form and then represent that binary number in this standard form and then represent it in a single or double precision form. Okay, so to represent any number in single or double precision format, there is one format used, and that is for single precision. The format is one bit is always your sign bit, 8 bits are of biased exponent, and 23 bits are significant bits, which is also called as mantissa. The bits after your binary point are called as a significant bits. The fractional part of your number is called as a significant bits or mantissa. Okay, so this is format for single precision. For double precision, one bit is always a sign bit, 11 bits are of biased exponent, and 23 bits are, sorry, not 23, 52. 52 bits are of mantissa. Okay. So this is the way to represent any number in the single or double precision format. Now, this is sign bit. So sign bit is positive. If the number is positive, sign bit will be 1. If number is negative, sign bit will be 0. In case of biased exponent, in single precision format, whatever is the actual exponent, this exponent, whatever it is, just add 127 to it to get the biased exponent. Okay. And in this case, and mantissa is the fractional part. This is your mantissa, which is indicated as M. So whatever will be after the binary point, which it will be all mantissa. In case of double precision format, again sign bit is if it is 1, that means number is negative. If number is positive, sign bit will be 0. The biased exponent will be your actual exponent plus 1023. So this is very important. So this is very important to be noted because this will remain same in case of single and double precision. Sign bit and mantissa. Mantissa will change only in case of the bits, that it will be represented and followed by zeros to get the 52 bits or 23 bits. But the biased exponent will be totally different. If you are representing a number in a single precision format, your actual exponent will be added with 127 to get the biased exponent for single precision, and the actual exponent will be added with 1023 to get the biased exponent in case of double precision. Okay, so we will see one example. Consider one example, 0.75. Now this example is in decimal form. So first you need to convert it into binary. So to convert any decimal number into binary, first you should know how to convert any decimal number into binary or binary into decimal. So this number multiply by 2, you will get 1.50. 0.5 into 2 will be 1.0. 0 into 2 will be 0. So go this way from top to bottom. Consider these numbers. This will be your 0.110 will be the binary representation of 0.110 will be binary representation of your 0.75. Okay. Now, as I have said, always a number will be represented in a normalized form like 1 point m. This form into 2 raised to your exponent, positive or negative. Okay. And it will be followed by a sign either plus or minus. Okay. So this is important to be noted. Okay. So this is important. Now represent this number in this format. So you will write it is with a negative sign 1.10. So I will move this decimal point towards right. If you are moving a decimal point or sorry, binary point towards right, the exponent will be decreased by 1 and it will be minus 1. Okay. So now here I will identify what is my sign bit. Sign is negative. So my sign bit will be 1. What will be my mantissa? Mantissa, the number which is followed by binary point will be my mantissa. So 1, 0, 0 all will be followed by 0. What will be my biased exponent? Biased exponent will be, now if I want to represent this number in a single precision format, biased exponent will be your actual exponent. This is my actual exponent minus 1. I will add it with 127, that is 126 will be my biased exponent if I want to represent in single precision format. And if I want to represent in a double precision format, my biased exponent will be minus 1 plus 1023, that is 1022. Okay. So this is now decimal number represented in a binary form. Okay. So this will be 0, 1, 1, 1, 1, 1, 1, 0. This will be 0, 1, 1, 1, 1, 0. Okay. So now this is, you got all the bits, all the points which you want to represent any number in a format, single precision or double precision format. So for single precision format, first my 1 bit is sign bit. What is your sign bit? 1, because your number is negative. 8 bits are my biased exponent. So what is biased exponent for single precision format? This 0, 1, 1, 1, 1, 1, 1, 0. And 23 bits are my mantissa. This is my mantissa. 1, all will be followed by 22 zeros. So this will be my representation of a number in a single precision format. And if I want to represent the same in a double precision format, it will be, first will be my sign bit. This is again 1. 11 bits are my biased exponent. So this will be the biased exponent in case of double precision. Okay. And 52 bits are my mantissa, that is 1, and followed by zeros. Okay. So in this way, you can represent any number, whether it is decimal number or binary number given. Directly you have to identify. Now what is the first step for any number? Just remember, the first step is whatever is the given number. If number is decimal, first convert it into binary. Okay. And represent it in this format. Okay. If number is already in binary, again check. If it is not in the given required format, convert it into the required format. Okay, so these are the only ways to solve any example. And if you get in this format, this is your first, this will be your sign bit. Okay, this will tell you what the sign is. So if number is positive, the sign bit will be 0. If number is negative, sign bit will be 1. Mantissa, any fractional part means whatever is after the binary point, all will be your mantissa. And what is biased exponent? Whatever is the actual exponent plus 127 for single precision plus 1023 for double precision. Okay, and just represent in the format which I have told you. Okay, sign, biased exponent and mantissa. 8 bits, 1 bit, 8 bit, 23 bits, 1 bit, 11 bits, 52 bits for double precision and single precision. Is it clear? So if the number is given in decimal, convert it into binary and use this normalized form. Then only you will be able to represent any number in single precision or double precision format. And in reverse way also, it is very simple. Okay. To find out the number from given single or double precision format. Okay. Thank you.